So without further ado, Lynn, would you like to introduce Dr. C?
I guess that would be me.
Yeah,
Do we have another slide?
we do.
Okay, there we go. I am very pleased to introduce Dr. C, for which we usually don't pronounce his name because it's very complicated, but Czajkowski, I think. And he is a professor at the University of Toledo in Ohio. He has been a mentor for N3 for all of the years that we've been doing the intern program. And he is earth scientist and studies all those things that are listed there: meteorology, GIS, which is geographic information systems, and remote sensing applications. And one of his interns is actually here today, Will, so otherwise listed as WCGUT. And so that was his project last year about urban heat islands, which was very inspirational to me. So we're doing a lesson based on what Will did for one of my other projects that's funded by the Department of Education. But most importantly, Dr. C is the PI for the Globe Mission Earth NASA funded project, which is just an awesome citizen science, earth science project. And I hope he tells us something about that today as well as urban heat islands, which are very interesting. And I've been observing them in my own local area. So take it away, Dr. C.
All right, well, thanks. I did want to mention something, Sid posted, what do you do? Make sure, if you don't miss something. And I always sat in the second row in class, never the first or the back of the room, because I always watched what the people in front of me were doing to make sure I was on task. I knew I wasn't missing something. In your front, maybe you miss something. And I always miss stuff. And if you're in back, then, the kids in back are unruly and not paying attention necessarily. So second row is always my go-to place to sit so as not to miss things in class, in college. In high school, you can't really choose where you sit, but in college you can. So, all right. Well, I want to thank you all for coming, and I'm going to try to talk a little here about urban heat island. And I did text Will in the chat. We didn't discuss earlier, but when it comes up to his project, he'll talk about it a little bit. I just have 2 slides from his project. And let's see if I'll share my screen. All right. So, of course, I've given talks. Let's see. There you go. Many times on urban heat island. It's something I have been working on or thinking about for a long time. And as Lynn mentioned, it's part of the Globe Mission Earth project, and it's another funded science activation project, so similar to N3. And we have partners across the United States working with students, doing projects, science projects, and then having the students present those projects at conferences. So I want to try to make this interactive a little bit. We'll see how it goes, and have some websites to go to. But in your experience, what heat islands have you seen every day? And what are the warmest and coldest places that you have seen outside? So maybe that's 2 questions. So how about we start with the first one, heat islands. And if you could put in the chat, it's called like a waterfall. What are some of the places you've seen at heat island? I'll make my box bigger. See, Los Angeles came up, Manhattan. Yeah, Washington, D.C. Probably Boston. I saw a paper recently about Boston in which plants are growing earlier in the spring by 2 or 3 weeks in Boston versus the rural area around Boston. Hawaii is the hottest place. Okay, so I guess we could switch to what are the hottest and coldest places that you've been in. Oh, Nick, I like that. When your car is close to the house, it doesn't have frost on it, but when it's far away from the house, it does. And that's exactly right. Your house can keep things warmer, and that's your house. And think about a whole city full of houses, and that can be a really big urban heat island. Norway, good. That's probably the coldest. Is that right? Okay. Hottest Mexico. Banff. Wow. I've always thought of going to Banff. That'd be pretty neat. I was in India for Globe, and we did a training and had a meeting in India, and that was the hottest place I've ever been in. And I got heat stroke. Coldest Canada. Where's the coldest I've been? I don't know. I know in where I went to school in New York is in Oneonta in the middle of the state. It was -27 one morning, and I had to work. So I was walking to work. I don't know, a couple blocks or so. Yeah, India also is very humid. All right, so those are great answers by everybody. Thank you. Okay, so I made my chat box too big. All right, so let's talk a little bit about the energy budget and surface temperature. We're going to look at surface temperature. That's how we measure urban heat island. So with the energy budget, the sun is our source of energy for the surface of the earth. And the energy comes through the atmosphere, interacts with the ground, and that's our surface temperature. But some of the energy gets evaporated or transpired by trees and plants, so that's evapotranspiration. Some turns into sensible heat, which is the heat we feel, so the air temperature. And then some of the energy is emitted to space. And we can ignore the energy going into the ground because then it comes out of the ground later in the year. So the energy that's emitted to space, that's the energy that's absorbed by greenhouse gases. And of course, we hear a lot about how greenhouse gases are increasing in our atmosphere. And that's how climate change is considered, where the greenhouse gases, as we put more in the atmosphere, more are absorbing the heat and it's staying warmer. Okay, let's see. So the urban areas, so in this schematic showing how the urban areas tend to be warmer, rural areas tend to be cooler. We have more trees. So the urban area, we have the buildings, the pavement, the parking lots. My best example personally of urban heat island actually occurred in the winter. My son had a soccer game in a dome on the other side of Toledo, and it was -8 degrees Fahrenheit when we left the dome. We drove through Toledo, and inside Toledo it got up to 7 degrees Fahrenheit. But then when I got to my house on the other side of Toledo in the rural area where we live, it was -11 Fahrenheit. So it was 18 degrees Fahrenheit difference between the city and our house in the rural area. So the urban heat island can happen in the summer, fall, winter, spring, any season. It just means that the urban areas are warmer than the rural areas. All right, so on this one, I want some people to put in the chat. Do you see any cities? So red is hotter on this. Blue is cooler. So the Great Lakes are cool. This is from April, the image. And so do you see any cities? And can you name the city? I guess that's what to put in the chat, is the name of the city. So we have Lake Erie, Lake Huron. Yeah, it's hotter near Chicago. Good. Detroit. Yeah, Detroit's this big one. Now, these little flags, these are schools I was working with at the time I made the graphic. And so, yeah, Detroit has a big urban heat island. Buffalo. Yeah, of course, I grew up near Buffalo. I don't know if anybody knew that, but I used to go fishing in the Niagara River right there every day after school. Yeah, is Michigan supposed to be cold? Now, sometime, in the summer, it's warm in Michigan, of course. No, I didn't know it, Lynn, that you're from Buffalo too. We have Cleveland here. What's the city south of Cleveland? Fremont? Fremont's more kind of to the west. Could be one of these little dots here.
Columbus, maybe?
No, Columbus is way down here,
Oh.
in the center of Ohio. But what city is LeBron James from? Akron. There you go. So Akron is right there, and then we can see there's Pittsburgh And even Toronto shows up on this image. Now, the other thing, though, to the west, there's a lot of red, a lot of hot. That's actually farm fields. So in the spring, farm fields are hot. They're hotter than the trees and that type of thing. All right, so let's go to our next slide. All right, so here's a website to go to. Let me put it in the chat. Let's see if I can do that seamlessly, right? I don't know if I can't do anything seamlessly, but yeah. Okay, so if you want to go to this website, it's the Urban Heat Island for Students. Let's see here. And of course, the Zoom thing always gets in the way, doesn't it? So I want you all to take a minute or two to take a look at this website we put together. We made this Bitmojis of me, kind of be fun, have that fun stuff. There's some video, there's photos of students taking temperature with infrared thermometers. So you're measuring the surface temperature. There's instructions of how to take the surface temperature. There's instructions on how to do a project, a science project, and also what Urban Heat Island is. I'll give you a minute or two to look at that. So Sid asked the question, where does the energy absorbed by the ground go? It can go to all those places I mentioned. So it could go into evaporating water or evapotranspiration. Some could go into plants, and that would be transpiration. So evapotranspiration. Some could go into heating the air above it. So first you have conduction, where the ground heats the air right above it, and that's through conduction. And then convection, the air starts moving around, and that spreads the heat around in the atmosphere. These are all these good physics terms. I know some of you are probably taking physics, or I may have already done that. There's a lot of physics in atmospheric science. All right, so I'm going to start moving on. So globe, boy, I don't know. Linda, have you talked about globe, or have people talked about globe in this program?
No.
Oh, okay.
You'll
I
be
forgot about.
You'll be the first person to give a talk about globe.
Okay, well, I forgot to kind of include some background slides on globe. So, all right, so I'm gonna they call it audible and go to globe.gov. So GLOBE is a program for students, teachers, and citizen scientists around the world. And it's to engage everyone in taking observations of our environment so as to learn about it. So globe.gov is the website. And if we scroll down, you can see there's data. So we're going to, people take data on rain depth, cloud cover, air temperature. If I scroll down a little bit more, it's in 127 countries. You can see all the educators involved, 263,000 globe observers. So these are citizen scientists who take observations, and 242 million observations have been taken so far and put on the database. So this is big data. So if you hear about big data at school, GLOBE is a big data program. It's set up as Earth as a system, where we look at the atmosphere, biosphere, pedosphere, and hydrosphere, and then how those spheres interact with each other, and that's Earth as a system. And then we could see who has, produced the most observations in the last 30 days for all these different things. We could look at mosquito habitat map, who's done that. So for these people from around the world, different countries, so it's a really international program, really interesting, cool. Tree height is another one I think is really neat. Okay, so here's different schools took observations of tree height, and then I do the surface temperature. I developed surface temperature, which is interesting. It's a surface temperature or surface temperatures. So this Brazil school is actually in Trinidad and Tobago. So they're number one, which is really cool. So I've talked to their classes or their teachers many times. And I'll say, oh, St. Peter's is in, I think that's in Ohio. Maybe not. It doesn't look like the teacher's name. It might be in another country. Hawkins is in Toledo. Margaretta's in Ohio. So anyway, you can see how you can see all the different students, what they're doing, what other people are doing. There's training you can do online. You can, a lot of learning activities, and then there's the database. You can take observations of the globe observer, that type of thing. Okay, so going back to what do, is I do surface temperature in urban heat island with the globe program. And we really focus on October, December, and March, because that's when the school year is, and we try to engage students in taking cloud, air temperature, surface temperature observations. So I'm going to just show you a few things about the globe program. We use these infrared thermometers. I think everybody's pretty familiar with those. Here we were in India when I took this picture. Matt was a college student at the time. He was a high school student when he started in Globe, and then became what they call Globe alumni. And then here's just a picture, a map of the different places where surface temperature is taken. So people observing urban heat island around the world and studying urban heat island. And, it's just a lot of fun. I'm going to show you a few countries and projects. Also, air temperature is part of it. So here's all the places taking air temperatures. Now, the big dots are stations, weather stations that are collecting continuously, where the small dots are where people have taken observations as an individual. So I'll just talk about a few international projects. I'll show you, what is going on around the world. So the Netherlands did a urban heat island project. They actually did a number of projects. I can't read all the words here, but Brian Campbell did trees around the world, around globe. I did urban heat island, and these other people did other things. And just to show you how in the Netherlands, they had kind of a bunch of schools, and they looked at the temperatures in a small area here. Here's Toledo. And what I've been able to do last year, I had my students take observations, and I work with schools in Toledo. So we get a lot of data that way to look at urban heat island. Greek students made a video, and they studied their urban heat island in their area. Another project was a joint project between Ireland, Malta, and Israel. And they did this one where, how can they keep their schools cool? And so the schools collaborated, and I facilitated or helped out, I guess. And the interesting thing was, for Europe and in the Middle East, I had to meet with them at 4 a.m. my time. It was in the middle of the day for them. So I was a little tired. But one of the interesting results was this AstroTurf of their playground was very hot. So, it's artificial turf that's used a lot of times, is actually turns out the hottest material. And yet we put it on playgrounds for students. I don't know, I have this. Can anybody guess how hot in Celsius this surface was? If you could put that in the chat. How hot was the surface in Celsius? Well, you probably 40 C, okay, 50, 43, I like that, 60. We have the rhyme, 30 is hot in Celsius, 20 is nice, 10 is cool, and 0 is ice. So 30 is a hot day. All right, it was actually 70 degrees Celsius. So no one guessed quite hot enough. So that's really hot. It's like 150 degrees Fahrenheit or something like that. Actually, someone could look that up, I'm sure, while I'm talking. All right, am I doing something? Oh, okay. Am I doing this right? Okay. So here's some more data. Let me just keep going through. 158, thank you, Ariana. Now, I mentioned that we try to have students do projects, and we give them opportunities to present. So we have local projects, We have a conference every year and have the students present their posters. It's like a science fair. We have in the United States regional globe conferences, and if someone were interested, you could contact me and you can be involved. And then there's the International Virtual Science Symposium, which students submit their projects virtually. And here's some projects, example questions. Which surfaces are hotter? How do the local weather conditions affect the temperature in different materials? And of course, how does the surface temperature at my school compare to another school, or different parts around the school? And you're right that the artificial turf can pose a safety risk to the students or the kids. Also, if we've had many schools do observations of their playgrounds, and like the metal sometimes can get very hot. So I don't know if you've ever, been on the monkey bars and it's so hot you can't touch it. So that's something. All right, so Will, do you want to jump in here and talk about your project a little bit? These are the two slides I have. I have your intro.
Yeah, sure.
and
Yeah, sure. I am a little bit under the weather, but yeah, I can
Sorry.
give an explanation. So I did a little review based on and did a bit of data science going around my town, because I knew all of the different materials that my town streets were paved with. That's Urbana, Illinois. And I went around, measured them, basically to calibrate data from Globe, like satellite data from Globe, superimposed that over a map, and kind of got these like rough averages of on how much they would heat up over like the temperature per day. And like basically a large part of it is albedo, which is like the amount of light that is absorbed or diffracted off of the surface. So high albedo means generally lower temperatures, because less of it is absorbed straight into the material and it heats up less. There's a lot of different approaches to doing this. For one thing, permeable pavers seem to like perform really well, and in this, even if because they're able to much more easily essentially kind of dump heat into the soil and sort of evaporatively cool themselves by essentially just kind of evaporating moisture as opposed to just heating up and having to cool themselves by black body radiation alone.
Well, thanks, Will. And I'll mention Will did a great job on this project, and you went out, I think it was like 30 days in a row or something.
Yep.
Throughout a heat wave, and your mom was concerned that you're going out in the heat, taking observations so much, but you did a great job. And I use this, your work whenever I talk, and I, of course, give you credit for it, because it's such a great project, and it does show the difference, how the permeable pavers are so much cooler than the asphalt. So thank you for doing such a great project. All right.
Thank you.
You're welcome. And so here's another project. I worked with a teacher in Dominican Republic, and Maria said that in the Dominican Republic, they made all the playgrounds asphalt into basketball courts, because they wanted all the kids to become basketball stars and be in the NBA, professional basketball players. And of course, they're not all going to be professional basketball players. They were just getting cooked. So the kids said, well, how can we make it cooler? And they found that green paint, painting the surface green made it the coolest. And so it was a great project. Here's a project a student of mine did last year looking at the University of Toledo, and undergrad student from Thailand, actually, she was visiting from Thailand. And the university is at Q5 in the center. And of course, they had the highest temperatures and the lowest amount of vegetation. So those are usually inversely related. And so on the next slide, let's see if I can get there we go. You can see how we have NDVI, that's the vegetation index on the x-axis, on the y-axis, the temperature, and there's this negative relationship. And the letters and numbers that corresponds to the different locations. Q5 being the hottest and having the least amount of vegetation is the university. And of course, it has the artificial turf. And then the parks nearby, there's Ottawa Park up in Q7 that has the coolest temperatures and the most vegetation. So that evapotranspiration really helps. And in the chat, it says, why not white paint, Chris says. Well, sometimes white can be too reflective. And in a way, it kind of heats you up by reflecting the sun on you. And I've seen that before, being on top of a white roof before and getting kind of heated up. Here's some data, globe data from the University of Toledo. You can see the football stadium here is artificial turf, and then the soccer field's artificial turf. Those are the hottest surfaces. And we have this grassy field where the band practices, that's a little bit cooler. So the grass is cooler. Even asphalt is cooler than the artificial turf, which is amazing. I just want to show you a fun thing. This is part of the Aaron project. They make Terra rovers. So this is something maybe to engage you with, is you can make yourself a robot built out of these Raspberry Pis and all that home computer stuff. So, and then drive it around. That's fun. And this shows again the artificial turf of the football field is red. It's hot. As soon as we drove it away on the concrete, and then even on the asphalt, it was blue, cooler. Crazy, huh? I'm gonna skip through a few of these. Did want to mention this one here, AGU Bright Stars. Now we have had students present at AGU as high school students. AGU is the American Geophysical Union. It's the largest, I would say, scientific conference in the world, I think. It's certainly the largest one that deals with climate change. And here's a picture on the right. You see all the scientists milling around, walking around, their posters, talking to each other, sharing their science. And students can do that as well, high school students. And I know as part of the science activation, the C's interns have been able to do the Bright Stars, and maybe some of the N3 could do it next year. I don't know if any did it this year, but bringing it up this year so that we can think about it as a group. Let's see. I did want to show you, this is one thing I wanted to show you guys and put in the chat. I know this is a way to look at urban heat on and remote sensing on your own. So let me make sure I send it to everybody. Put the link in the chat, and I'll show you how to use it really quickly. So here's the website. It was first started by an intern at NASA Langley, and then one of my students took over and added to it. So it uses Google Earth Engine. I chose Landsat 8, and then you can choose the data sets. I'll just choose them all. I have to draw a box. Let's see if I can do that. So I click on, I have to zoom in on a city. Oh, maybe some people say, oh, South Dakota can't have urban heat on, right? Because it's so rural. I bet it does. So let's look at this really small town. I got to draw a box around it. All right. And hopefully it works. We were having trouble in my class today. I'm going to go pick dates. I'm in the summer, June 1st. The end date, and it picks a range. You have to pick a range, because if you don't pick a range, then you might not get an image, because there's you have to pick a temperature range, pick 10 to 30 Celsius, and then do add data. Okay, just bringing up an image, because the image, oh, okay, it didn't work. The temperature range wasn't right. Let me pick. I think I have to go hotter. Pick it again. All right, there we go. All right, there it is. So we can see in the center, here's the urban heat island for this little place in South Dakota. Now, some of the farm fields are warm too. I mentioned a little bit about that. You know, the farmers want the farm fields to be warm so the plants grow faster. But I wanted to give you a chance to try it out. But I want you could try it on your own after our talk. And this is really cool. Yeah, Sid put it cool. Because you know what? I have worked on this. I've been a professor for 26 years. And then before that, I was a postdoc for 3 years. So I guess 29 years working on remote sensing. And last year, so after 28 years, to get it to the point where it's easy for students to get this thermal imagery to look at their own neighborhoods. I mean, this is quite a we call journey to get to this point. And you know, it's so exciting to me that you can go anywhere in the world and look at the urban heat island or thermal remote sensing for a different reason. You might have a different reason for, well, you might look at a glacier, I guess. Look at the temperature of a glacier. So I'm just like coming up with ideas off the top of my head here. Because that's what sometimes scientists do. All right, so I'm going to draw a box around this glacier. You can see the glacier, it's got the outflow and stuff like that. I bet it's going to be colder, so I have to pick. I'll do 0 to 25. Let's see if that. Of course, the snow might be below. Oh, okay, it comes up. There you go. Look at that. The glacier is cold. Makes sense, I guess, right? We can see, though, there's parts of the outflow part of the glacier where it's red, right? And that's when the debris gets on the glacier. The glacier starts to melt. You get the dirt on the glacier and it absorbs sunlight. So it gets hot and it melts the glacier further. So anyway, that's something there. So this is something I think hopefully you'll have fun looking at. And I'll just finish up my PowerPoint here. We did do a study in Toledo this past summer where we had people volunteers driving the roads and mapping it. And that was part of a NOAA funded project. And many cities in the United States have done that. I just wanted to end with that. And here's some of my websites and stuff like that. All right. Well, thank you. I wanted to thank you for paying attention, and everybody's doing their active learning and posting things in the chat. I know I missed a lot of questions.
Yeah, let's see. I know Lynn tries to answer questions as we go to make sure there's time for everything. So I think
I thought you did a good job, Lynn.
you answered a lot of them as we went.
Okay. Well, and most importantly, I pasted in the link to the urban heat island viewer, so that
Oh, okay.
try
Did I
it
not?
themselves.
Oh yeah, I got okay.
It's like you were working on pasting it in, but then you got excited looking at all the maps. I have to say that that tool is so much fun, and I did it with all my teachers. We all did our hometowns. I did my hometown just so I could recognize various things, and I knew what they were made of. Like, here's the shopping center, and here's my ranch, and here's the water treatment place where there's all the different kinds of water, and it was just fascinating. So I encourage everybody to try it for sure.
Yeah, Google Earth Engine has some things that are really interesting to work on, and you can do some coding in Google Earth Engine to make things of your own.
Sid has been asking some bigger questions about how the sun heats things up.
Well, I don't know if you guys remember all these things like the duality of light. So light travels as an electromagnetic wave or as a particle, something like that. I'm not an expert on this, but so, when electromagnetic spectrum is a wave and the wave contains energy, and so the energy from the sun is traveling through the vacuum of space and it's not being affected by space. And then, when it impinges on the earth, it heats up the earth. Or of course, it heats up you too, right? If you're out in the sun. So that's how it works, is through the electromagnetic spectrum. Now, the earth cools itself through the electromagnetic spectrum as well, and it cools itself according to its own temperature. And so, let's see, we use Wien's displacement law to calculate the wavelength that the object emits according to its temperature. So the average temperature of the sun, we always say, is about 6,000 degrees Celsius or Kelvin, sorry, 6,000 Kelvin. And that comes up with a peak wavelength of 0.5 micrometers, whereas the temperature of the Earth is about 300 Kelvin. So 300 Kelvin is, was that like 27 Celsius or something like that? So we're rounding because it's actually like more like 288 Kelvin is the temperature of the Earth's surface on average. And that works out to peak wavelength of 10 micrometers. So the Earth is emitting at 10 micrometers out to space, while the sun is emitting at, the visible light, 0.5 micrometers towards Earth, and that's what the Earth is absorbing. Yes, and Lynn's has the transfer, through, reflection, and absorption are the three ways that energy is impacted by an object. And then conduction is actual vibration. So they're next to each other vibrating, and it transfers this is a lot of good physics stuff here today. And then convection is the actual movement of the air.
Do you have any other questions for Dr. C before we say?
Well, why is artificial turf so hot?
Oh, yeah.
That's a good question. Generally, it's dry, right? Because it doesn't have water on it, but it has the little black pellets from tires that are ground up. So usually to make it fluffy, they ground up old tires and throw it on the sports field. And you'll see it sometimes, like I don't know if you watch a football game or soccer game, a player steps and then these little black particles fly up in the air. That's old tires that are ground up. And I think that's why it's so hot, is it's black, right? So it's absorbing. It's just like Will said, the albedo makes a big difference. So these black particles on the artificial turf are absorbing the sunlight and getting hot. There's not a lot of water. Now I have suggested, and I haven't implemented this, is what if we watered the artificial turf field before a game, before the kids play? How much would that cool it down? And also, how much does that cost? Because that's what the first thing people ask at a school. How much is it going to cost to water the field? And of course, that's why people put up these artificial turf, is because you don't have to water, you don't have to mow the grass, you don't have to weed it and treat it and all that stuff. You put it in and it stays there pretty good for many, many years. All right.
Oh, that was just wonderful.